In previous class we saw how to design filter using rectangular window, that is low pass filter using rectangular window. Today let us see how to design an FIR filter using Hamming window. Okay. So the question is, find HD of n, H of n and H of omega for HD of omega which is equal to e power minus j3 omega when magnitude of omega is less than 3 pi by 4 using Hamming window. Okay. So we need to design the low pass filter with the help of this particular given desired frequency response using which type of window? Hamming window. So if I start solving for HD of n, so we all know HD of n is nothing but equal to 1 divided by 2 pi integral from, generally it is from minus omega c to plus omega c, HD of omega into e power j omega n into d omega. Okay. So what they are telling, we have this response for omega less than or equal to 3 pi by 4. So if I just draw the plot of omega with respect to HD of omega, so it will be equal to, for omega less than 3 pi by 4, let me assume 3 pi by 4 is here. So for this particular range we are getting the response. So if I take mirror image of this, what happens exactly at minus 3 pi by 4? We get the same response. Okay. Then the second thing what they are telling, from 3 pi by 4 to pi the value is 0. So from 3 pi by 4 to pi the value is 0, again here it will be 0. Okay. So now if I try to write the integral part, that is the limits of integration, so from where the response is starting, it is starting from minus 3 pi by 4, the lower limit, and the upper limit should be 3 pi by 4. We know we write it from left hand side to right hand side. So if I rewrite the equation of HD of n, 1 by 2 pi integral from minus 3 pi by 4 to 3 pi by 4. So what is HD of omega? Let me write it as it is, into e power j omega n d omega. So what is HD of omega in this interval? It is nothing but equal to e power minus j3 omega. So substitute that, 1 by 2 pi integral from minus 3 pi by 4 to plus 3 pi by 4 e power minus j 3 omega into e power j omega n into d omega. Now in this expression what let us do is, let us rewrite this exponential term as a single term. So if I do so, HD of n will be equal to 1 divided by 2 pi integral from minus 3 pi by 4 to plus 3 pi by 4 e power j omega. What I am doing is I am taking e power j omega as the common factor. So the term left out here is n and here it is minus 3. So into n minus 3 into d omega. Let us call this as equation star. Okay. Now let us start dealing with equation star. So if I solve for star, again I need to solve it with two cases. So let me start with case 1. In case 1, let the value of n be not equal to alpha. Okay. If I do this, so the equation star remains as it is, that is I can rewrite it as HD of n which is equal to 1 by 2 pi integral from minus 3 pi by 4 to plus 3 pi by 4 e power j omega n minus 3 into d omega. The equation remains as it is. what I need to do, I need to integrate this exponential term. So if we integrate that, it will be equal to 1 divided by 2 pi e power j omega n minus 3 divided by j into n minus 3 under the limits minus 3 pi by 4 to 3 pi by 4. Okay. Now what I can do, I can take this outside because I am substituting the limits for omega. So if I continue the simplification of case 1, hd of n will be equal to 1 divided by 2j into pi into n minus 3. So now what let us do is, let us apply the upper limit minus that of the lower limit. So if we apply the limits, the equation will be e power j 3 pi by 4 into n minus 3 minus e power minus j 3 pi by 4 into n minus 3. Okay. Now we know that the standard equation e power j theta minus e power minus j theta divided by 2j is nothing but equal to sin theta. So we have only e power j theta minus e power minus j theta. So what happens to RHS? It becomes 2j sin theta. So if I rewrite this equation in the standard format, so we can rewrite the equation as hd of n, which is equal to 2j into sin theta here is 3 pi by 4 into n minus 3 whole divided by 2j into pi n minus 3. So I can cancel 2j with 2j. So therefore, the value of hd of n when n is not equal to alpha is sin 3 pi by 4 into n minus 3 whole divided by pi into n minus 3. So this is the solution for case 1. Now in case 2, we should assume the value of n is equal to alpha. Let us start with case 2. So in case 2, let the value of n be equal to alpha in which equation? In equation star, which is nothing but this equation. So if n is equal to alpha, that is 3, so this entire term tends to 0. So e power 0 is 1. So what happens to hd of n? Therefore, hd of n will be equal to 1 divided by 2 pi integral from minus 3 pi by 4 to plus 3 pi by 4 1 into d omega. So if I integrate 1, so it will be 1 by 2 pi into omega under the limits 3 pi by 4 minus 3 pi by 4. So if we substitute the limits and simplify, 1 by 2 pi into the upper limit is 3 pi by 4 minus of minus 3 pi by 4. So minus into minus becomes plus. So I can write it as 1 by 2 pi. So it becomes plus. So the LCM will be 4. So this is 3 pi plus 3 pi. So 3 pi plus 3 pi is 6 pi. So if I continue the simplification, hd of n will be equal to 1 divided by 2 pi into 6 pi by 4. So now if I simplify this, I can cancel pi with pi, 2 with 6. So therefore, hd of n is 3 by 4. That is, whenever the value of n is equal to alpha, this is hd of n. I have written hd of n for both the cases. For n not equal to alpha, it is sin 3 pi by 4 n minus 3 divided by pi into n minus 3. Similarly, when n is equal to alpha, it will be equal to 3 by 4. Okay. So if I try to find out the value of m, we know alpha is equal to, what is alpha according to the given case? It is equal to 3. So which is equal to m minus 1 by 2. Okay. So if I try to find out m, so it is 6 which is equal to m minus 1. Therefore, m is equal to 7. So what I can tell, it is an odd number. Okay. Now we found out the value of m, we got hd of n. Now I need to find out h of n. Then with the help of h of n, we can find out h of omega. So in order to find out h of n, I need to draw a table. So the first element of the table will be small n. We know n ranges from 0 to m minus 1. Since the value of m is 7, this should range from 0 to 6, 0, 1, 2, 3, 4, 5 and 6. Then it should be hd of n. Then it is omega h of n. Why omega h? They are telling us to use Hamming window. And the last column is nothing but h of n, which is equal to omega h of n into hd of n. Okay. Now with the help of this table, we can find out h of n, and they are telling us to use Hamming window, and we know the expression for Hamming window is given by omega h of n, which is equal to 0.56 minus 0.54 minus 0.46 into cos 2 pi n divided by m minus 1. Now what we need to do, in the first case, we need to start finding out hd of n. So we have the expression for hd of n here. In this expression, start substituting the values of n as 0, 1, 2, 3, 4, 5, 6. We already have one value of hd of n, that is when n is equal to alpha. What is the value of alpha? The value of alpha is 3. When n is equal to 3, hd of n is nothing but equal to 3 by 4. That is, when n is equal to 3, hd of n is equal to 3 by 4, which is nothing but equal to 0.75. Okay, you can write this directly. Then start substituting the values of n as 0 in this equation. Find out what is hd of 0. Then substitute the value of n as 1. Find out what is the value of hd of 1. Similarly for hd of 2, hd of 4, hd of 5 and hd of 6. Okay. Then what we need to do, I need to find out omega h of n for all the n values. We have the standard expression for Hamming window. In this window, substitute the values for small n from 0 to 6 and try to find out the value of omega h of n. What I have done, I have substituted the values for n and I found out hd of n. Similarly, substituted the values of n in this equation and found out omega h of n. Now, in order to find out h of n, what I need to do? Multiply these two gives us the first value of h of n. Similarly, hd of 1 with omega h of 1 gives us h of n. Similarly, until here. Now, if I multiply minus 0.159 with 0.31, it gives us minus 0.0493. Similarly, multiplying 0.075 with 0.08 gives us 0.006. Okay. Now, looking into this h of n, so this is the center value. So, this is symmetric as this, yes or no? This is same as this and this is same as this. Therefore, what we can conclude, the value of m is odd and h of n is symmetric. Now, with the help of this table, what we did, we found out what is h of n. The second part of the question is done, and from this only we got one more data to find out h of omega, that is the condition of m is odd and h of n is symmetric. With the help of this, we will try to find out h of omega. We know the value of m is odd and h of n is symmetric. So So for this condition, the standard expression for h of omega is equal to h of m minus 1 by 2 plus 2 summation n ranging from 0 to m minus 3 by 2 into h of n into cos omega m minus 1 by 2 minus n into e power minus j alpha omega. Okay. So whatever value we know, we will substitute in this equation. We know m is 7 and alpha is equal to 3. So if I substitute, h of omega will be equal to h of 7 minus 1 by 2 plus 2 summation n ranging from 0 to 7 minus 3 is 4, 4 by 2 is 2, h of n into cos omega minus n into now let us simplify the terms inside bracket. So that is h of 7 minus 1 is 6, 6 by 2 is 3, h of 3 plus 2 into summation n ranging from 0 to 2 h of n into cos omega, again it is 3 minus n because 7 minus 1 is 6, 6 by 2 is 3 into e power minus j 3 omega. Okay. Now let us substitute the values of n in this part and let us expand the summation. So if we do so, h of 3 plus 2 into h of 0 cos 3 minus 0 is 3, 3 into omega is 3 omega plus h of 1 into cos 3 minus 1 is 2, 2 into omega is 2 omega plus h of 2 into cos, the value of n is 2, 3 minus 2 is 1, 1 into omega is omega. So let me close the bracket into e power minus j 3 omega. Okay. So do we know the values of h of 3, h of 0, h of 1 and h of 2? Yes. So substitute the values and if we find out, that gives us h of omega. After substituting the values of h of 3, h of 0, h of 1 and h of 2 and simplifying it, so this is the expression which we are going to get for h of omega. So this is how we can design an FIR low pass filter using any kind of window. So we have solved for Hamming window as well as rectangular window. You people can try for Bartlett window and Hanning window. The thing which changes is everything remains same. So whenever we tabulate or we try to find out h of n, the third column, that is the window column, there you need to write the expression of the respective window. To that expression you need to substitute the values of small n and try to find out the respective window functions and then multiply the desired impulse response with that of the respective window function. That gives us h of n. So now let us solve problems on band pass filters. This is the next question which is related to band pass filter, that is a filter is to be designed with the following desired frequency response. HD of omega, they have given the desired frequency response and they are telling us to find out the frequency response using rectangular window. So if I try to draw the response for this, that is the desired frequency response. So this is omega, HD of omega. So what they are telling, from minus pi by 4 to plus pi by 4, the value is 0. So this is minus pi by 4 and this is plus pi by 4. So the value is 0. Okay. Then from pi by 4 to pi, this is pi. So from pi by 4 to pi, it is equal to e power minus j to omega. So if I write, if I take mirror image of this, so from minus pi to minus pi by 4, we will get the same response. So looking into this, first I need to find out HD of n. Then with the help of HD of n, by using rectangular window, we need to find out H of n. Later we can find out the frequency response. Okay. So we know the expression for HD of n, which is equal to 1 divided by 2 pi integral from minus pi to plus pi HD of omega into e power j omega n into d omega. Now looking into this figure, we always write the limits from left hand side to right hand side. We get two integrals, one from minus pi to minus pi by 4, the other from plus pi by 4 to pi. So if I rewrite the expression, HD of n will be equal to 1 by 2 pi into integral from minus pi to minus pi by 4 HD of omega into e power j omega n into d omega plus integral from plus pi by 4 to pi HD of omega into e power j omega n into d omega. So we got this thing. Now what we know, from minus pi to minus pi by 4, HD of omega is nothing but equal to e power minus j 2 omega. Similarly, from pi by 4 to pi, this is nothing but equal to e power j minus 2 omega. So let us substitute the values and start simplifying. Therefore, HD of n is equal to 1 by 2 pi integral from minus pi to minus pi by 4 e power minus j 2 omega into e power j omega n into d omega plus integral from pi by 4 to pi e power minus j 2 omega into e power j omega n into d omega. Okay. Now instead of writing these two exponential terms separately, let us write it as a single exponential term. Here also, instead of writing two exponential terms separately, let us write it with a single exponential term. So if I rewrite the expression for HD of n, it will be equal to 1 by 2 pi integral from minus pi to minus pi by 4 e power j omega n minus 2 into d omega plus integral from pi by 4 to pi e power j omega n minus 2 d omega. Let us term this as equation star. Now we should deal with respect to two cases, both respect to equation star. So in case 1, let n be not equal to alpha in equation star. So your alpha is nothing but 2. So if n is not equal to 2, let us see what happens to HD of n. Okay. Therefore, HD of n will be equal to 1 by 2 pi. The equation remains same. So let me rewrite the equation as it is. Minus pi to minus pi by 4 e power plus j omega n minus 2 into d omega integral from pi by 4 to pi e power j omega n minus 2 into d omega. Now what I should do, I need to integrate the exponential term and I should try to find out HD of n. So let me integrate the exponential term. So HD of n will be equal to 1 divided by 2 pi into, if I integrate, it will be e power j omega n minus 2 divided by j into n minus 2 under the limits minus pi to minus pi by 4 plus, if I integrate the second term, it will be e power j omega n minus 2 whole divided by j into n minus 2 under the limits pi by 4 to pi. Now let us try to apply the limits. Therefore, hd of n will be equal to, I can take j n minus 2 as common factor in both the terms. So I can write it as 1 divided by 2j into n minus 2. So if we apply the limits, the first limit is e power minus j pi by 4 into n minus 2 minus e power minus j pi n minus 2 plus, if I apply limits for this, it is e power j pi n minus 2 plus, it should be minus e power j pi by 4 into n minus 2. Now, we have e power minus j theta here, we have e power plus j theta here, the same exponential power. Similarly, we have e power minus j theta here and e power plus j theta here. So, we can express these two pairs in terms of sign. Yes. So, if we rewrite, I can write it as, if we rewrite this in terms of sign, that will be equal to 2j into the first pair sine pi by 4 into n minus 2 plus 2j into sine, the second pair is pi into n minus 2 whole divided by 2j into pi into n minus 2. So, in the next step what I can do, I can take 2j as a common factor in the numerator. Yes. Therefore, hd of n will be equal to 2j into sine pi by 4 into n minus 2 plus sine pi into n minus 2 whole divided by 2j into pi n minus 2. Okay. So, now what we can do, I can cancel 2j with 2j. Therefore, the expression for hd of n when n is not equal to alpha will be equal to sine pi by 4 n minus 2 plus sine pi into n minus 2 whole divided by pi n minus 2. So, this is with respect to case 1. Now, I should do the same thing for case 2. So, if I start with case 2, let n be equal to alpha n star. So, this is our equation star. So, in this equation, if n is equal to 2, so 2 minus 2 is 0. So, the entire exponential term tends to 0. So, e power 0 is 1. Similarly, here if n is equal to 2, 2 minus 2 is 0. The exponential power tends to 0. E power 0 tends to 1. So, if I rewrite the equation, therefore, hd of n will be equal to 1 by 2 pi integral from minus pi to minus pi by 4 1 into d omega plus integral from pi by 4 to pi 1 into d omega. So, now if I integrate 1 with respect to omega gives us 2 pi omega under the limits minus pi to minus pi by 4 plus omega under the limits pi by 4 to pi. Now, if we substitute the limits, so the expression for hd of n will be 1 by 2 pi into the upper limit is 1 minus pi by 4, minus of minus pi becomes plus pi, plus the upper limit is pi minus pi by 4. So, if I simplify this, I can take LCM. So, the LCM is 4. So, in the numerator it will be minus pi plus 4 pi plus 4 pi minus pi So 4 pi plus 4 pi is 8 pi, 8 pi minus pi is 7 pi, 7 pi minus pi is 6 pi. Therefore, this is equal to 1 by 2 pi into 6 pi by 4, where we can cancel pi with pi, 2 with 6. Therefore, the left out term is 3 by 4. Okay. So, now if I summarize, this is the expression for HD of n when n is not equal to alpha. When it is equal to alpha, the value of HD of n is 3 by 4 when it is equal to alpha. Okay. So, this is the first part. Now, with the help of HD of n, we need to find out h of n, which helps us to find out the frequency response of the given filter. If I draw the table, so the first column is n, followed by HD of n, followed by omega r of n. Why omega r? Because they are telling us to use rectangular window. And finally it is h of n, which is equal to HD of n into omega r of n. Okay. So, we know the value of alpha according to the given expression is 2, and this will be equal to m minus 1 by 2. So, if I try to find out the value of m, if I cross multiply these two, 2 into 2 gives us 4. So, this becomes 4, which is equal to m minus 1. Therefore, the value of m is equal to 5. So, we got the first case, that is m is odd. Now, what I need to do? I should use rectangular window. So, what is the formula for rectangular window? So, omega r of n will be always equal to 1 for n greater than or equal to 0 and lesser than m minus 1, and 0 otherwise. We know this also. So, the value of m is 5. If the value of m is 5, the small n ranges from 0 to m minus 1. So, the values of n is 0, 1, 2, 3 and 4. Okay. And we know omega r of n will be equal to 1 from 0 to m minus 1. Yes. So, for all the values of n, this is also equal to 1. Now, what I should do? I should find out HD of n from the expressions which we obtained, that is, we need to substitute the values of n in that expression and we need to tabulate HD of n. I have tabulated the values of HD of n. Okay, now if I try to find out h of n, it is nothing but multiplication of these two, which gives us minus 0.159. Again, multiplying these two gives us minus 0.225. Multiplying 0.7 with 1 gives us 0.75 only. Multiplying these two gives us 0.225. Multiplying these two gives us minus 0.159. Okay. Now, looking into h of n, which we have obtained, it is symmetric. So, if I take this as a center value, these two are symmetric, these two are symmetric. Therefore, what is the condition? We know m is odd and h of n is symmetric. So, with this condition, so what will be the expression for h of omega? So, h of omega will be equal to h of m minus 1 by 2 plus 2 into summation n ranges from 0 to m minus 3 by 2 into h of n into cos omega m minus 1 by 2 minus n into e power minus j alpha omega. So, we know the value of m, we know the value of alpha. Let us substitute in this expression. Therefore, h of omega will be equal to h into, so the value of m is 5. So, 5 minus 1 is 4, 4 by 2 is 2 plus 2 into summation n ranging from 0 to 5, 5 minus 3 is 2, 2 by 2 is 1, h of 1 into cos omega 2 minus n into e power minus j 2 omega. The value of alpha is 2. Now let us expand the summation. So if I expand the summation, h of omega will be equal to h of 2 plus 2 into h of 0 into cos 2 omega plus 2 into h of 1 into cos omega into e power minus j 2 alpha. Now we know the values of h of 2, h of 0 and h of 1. So it is here only. Let us tabulate. So h of 2 is this value, that is 0.75 plus 2 into h of 0 is minus 0.159 cos 2 omega plus 2 into h of 1 is minus 0.225 cos omega into e power minus j 2 omega. So now multiplying all these terms gives us the expression for h of omega. If I multiply 2 with minus 0.159, we are going to get minus 0.318. Similarly, if I multiply 2 with minus 0.225 gives us minus 0.45. So this is nothing but the expression for h of omega. This is how we can find out or design an FIR low pass filter or band pass filter using any kind of window. So they may give problems related to high pass filter also. From next class we will start with the realization part of a FIR filter. The main thing what we should remember in design part is we need to remember the condition, that is symmetric and antisymmetric condition. We have 4 conditions. When M is even and symmetric, when M is odd and symmetric. The third condition is when M is even and antisymmetric, when M is odd antisymmetric. These 4 conditions are important and the formulas associated with these 4 cases are important. Along with that, the expression for all the windows, all the types of windows, that is rectangular, Bartlett, Hamming and Hanning is very important. Why? They may ask you to design the filter using any kind of window. It may be rectangular, Bartlett, Hamming or Hanning. So if you remember the formula, it is very easy to compute. So the procedure to design a filter is, first we need to design HD of n. Then with the help of HD of n, we try to find out h of n. Then we will check whether h of n is symmetric and what is the condition for m. So based on the condition, we take the frequency response of that particular condition and we try to find out the frequency response of the given filter. So thank you.